Okay, so today's lesson is going to be about the scientific process that is known as scientific inquiry. And what we're going to do is we're going to go over what this process is, and I'm going to do this by outlining each of the individual steps that make up the method, and by giving little examples of each to show how the scientific inquiry is done. So the best place for us to start is by getting a basic understanding of what science really is. And science is just our way of making sense of or understanding the things that we encounter and just don't quite understand, or as a way of understanding the unknown. The process of finding the answers to these questions is what scientific inquiry is all about. Scientific inquiry is the stepping stones that are followed by scientists as they try and make sense of these unknowns in the world. So the best way to think of scientific inquiry is a method that is broken up into different steps that must be followed in order to reach the ultimate goal of finding some sort of an answer. So let's say I was at home and I was doing some work, and I was doing this with a black ink pen. While I was doing my work, I also had a glass of water with me that I was drinking. When I went to take a drink of my water, a small drop had fallen from the cup and onto my work, and it smeared the ink writing. However, when it did this, I noticed that the black ink had smeared into a couple different colors. What just happened here was that I made an observation. I noticed something that was not what I had expected, and it was causing me some confusion. I would have thought it smeared and it should smear all black, but instead I was seeing different colors. Because I seen this, this led to me making a question. It is by making an observation and having this confusion that is leading someone to asking a question. So seeing the smear mark being more than one color led me to ask, are there multiple colors in the black ink of my pen? So right here I have two questions posted on the slide. They are, why are questions important in science? And what if you didn't begin with a question? And those are two questions I would pose to my class, and they would go over and as a groups or class-wide just kind of discuss them amongst themselves. And I would then go further into the PowerPoint, and they will be explained a little bit later on. So without asking these questions, there really is no start to the scientific process. The questions literally are the building blocks of inquiry, and this means that if some observation did not lead to the asking of a question, there would not be anything to try and figure out, and the process would just stop right there. Without the asking of the question, there would be no start to the scientific inquiry. The question is a logical start point for quite a few reasons. Think about if you made just the same observation, that the ink smeared into different colors. And instead of asking, are there multiple colors in the ink, that you just decided to pour more water onto the paper and see what happens. Without asking this question, the act of pouring the water on the ink is really pointless, because there was no reason to do this. You haven't asked the question which will lead you to find something out. You are just pouring the water and you aren't really looking for anything. Without asking this question in the beginning, the process of inquiry becomes unorganized, because you really don't know what you're looking for. You're just going through different steps. So now that we have established this question, are there multiple colors in the ink, there of course has to be some sort of answer to it. Based on the observation we made, we can make a few different educated guesses on what could be some possible answers. These educated guesses are what are known as the hypothesis. So let's just say we have come up with two hypotheses, two possible answers for our question. First, we say that there are multiple colors in the ink, but then we also give the possibility that there really isn't, that there is only one color in the ink. What this is called is a null hypothesis, because what it is stating is that there will be no difference. It is pretty much saying that nothing is going to happen when the experiment is run. Since we now have these two possible answers to the questions, it is time to find a way to test this out and see what the true answer is. We have to figure out a way to take the black ink and separate it into its different parts. This will allow us to see if there are multiple colors. We know that we observed the change when the ink got wet. So maybe if we create some sort of test where we get water to travel through some of the ink and getting it to separate into different colors, we can see if there really are more than one colors in the ink. And actually what this type of test is called is a chromatography experiment. And this will be the perfect test for us to do to see if there are multiple colors in the ink. So for the experiment, what we're going to do is we're going to take a few long strips of paper. And at the very bottom of the paper, we will mark it with the pen. We'll then take a cup or a beaker and fill it with just a little bit of water. These marked papers are then going to be hung from the top of the beaker with a pencil or a pen or something that's going to keep them in a steady position. And this way, they're going to be hung so just the very tips of the paper are touching the water. So just kind of in your life, you might have observed that when you get a piece of paper or a paper towel wet, that the liquid travels through the paper. It doesn't just like get in the paper and stop. It'll slowly make its way through the entire piece of paper. And this is exactly how a chromatography experiment works. The paper will touch the water just enough to allow the water to get into it, and then will travel up the piece of paper. As it travels up the paper, it'll pass through the ink, hopefully smearing it and spreading it just like we've seen with our homework. On this slide there's a picture that has the three pieces of paper in the beaker, and this is the perfect way to set up the experiment. You can see the three dots where someone marked it with the ink, and the water is barely touching the edge of the paper. The water will run up and hopefully smear the ink, and we will try to find if there are multiple colors. So we let the experiment run for a few hours, and then we came back to it to see what happened. What we seen was that the paper strips were completely saturated with the water, and so that means it absorbed all the way up the piece of paper. In this process of going all the way up the paper, the water went through the ink that we put on it, and this smeared it. This means that our chromatography experiment has worked. When the ink got smeared up the paper, we then noticed it was broken up into the different colors, just like we had hypothesized. So once the experimentation is complete, we now have some data to work with. In some cases, data can be numbers or figures that were measured or calculated in the experiment. But in our case, we just have the multiple colored ink smears on the different pieces of paper that we had gotten from our chromatography test. The data that is collected then needs to be analyzed. So by looking at the data, we must figure out what the outcome means. It is this analysis that helps us get closer to an actual answer for our initial question. But more importantly, it shows us if our hypotheses were correct or incorrect. So, with the data that we collected, the analysis shows that the ink, in fact, did produce multiple colors. What this experimentation proved was that the ink that was in the black pen really was not just black, but was actually a mixture of multiple colors. Now that we have come up with this conclusion, that the inks are the multiple colored and not just black, we must match this up against our previous hypothesis to see if it was incorrect or correct. So our first hypothesis that we made was that there were multiple colors in the ink. And by doing the experimentation and then analyzing the pieces of paper, we decided that this is true. So our results that we found supported our hypothesis. However, this does not mean that we are done and we have some set answer. Maybe there are some things out there that are an exception to this rule. Or maybe this ink pen was just the exception to this rule. So right here I have posed a question that on the slide it says, are there any variables that affect the outcome? And as a class I would discuss this and we would talk and they would give me some examples to various variables that could affect it and made this not true. Our second hypothesis, or our null hypothesis, was that there was only the black color in the ink pen. However, the results that we obtained from the experimentation did not agree or support this guess. What happened was we have proved our null hypothesis wrong. Sometimes scientists will create these null hypotheses that they will think because they know they will be incorrect. and that way they can be proved incorrect. So with this outcome, we have determined that there is not just the one color, and in fact there are the multiple colors. But, just like our other hypothesis that was correct, we cannot just stop here and say we found an answer. And once again, I've posed the question that says, what would be your next step? And I will again have the class-wide discussion, and they will give me some ideas as to what they would do next with this situation, as it was false. So no matter what your outcome is, if it's correct or incorrect, you have to redo the experiment. There are just so many variables out there that could have occurred that could change the outcome. Maybe there are other pens that are actually just the one ink. Maybe blue pens or red pens use just one single colored ink. Maybe different pen companies do different things with their inks, and so on. By redoing the test over and over again and using different pens or using different inks or different colors, we can make sure that all the possible errors are eliminated from our testing and we can get a solid answer. If after this redo, and we continuously redoing it, and we continue to come to some same result, we're finding the same thing, we know that it's not just a coincidence, and that we have actually found an answer to the question that we were looking for. So with most typical scientific findings, the results and conclusions become published in scientific reports and write-ups. These are made so that the public can look over your findings and see why the answers to your questions were what they were. They're like saying, why was the color of the ink really different? And they could see how you went about it and why it really was that way. However, you cannot just write up your findings and have them published instantly. Once you have found your results and you've put them in reports, they have to go through this strict process called peer revision. This allows others to see your processes, read your findings, and perhaps find some mistakes that you made, or find places where they can expand on your experiment and help make your findings more accurate. It is this peer revision process that actually finalizes the process and allows you to get to your solid answer. So, what you've just seen here is the scientific process and the scientific method. And we have went through each of the steps in which a scientist would actually go through to answer some of the most complex of problems in the world. And just as a kind of basic overview once more, it all begins with making an initial observation, which is going to lead to some sort of question. Once you have this question, you're going to make some guesses as to what you think the answer will be, and these are called the hypotheses, or educated guesses. Once you have those, you're going to create some sort of test, and with this test you're going to get data. By analyzing this data, we can come to some sort of conclusion as to what actually is the answer to the question. But of course, it doesn't end there, and you must repeat it, and you must do multiple trials to make sure that you get the final answer. And it's by following these simple steps that some of the most difficult of scientific questions have been answered and attempted. So that is the scientific method and process.